Solicited node multicast groups in IPv6. If you've heard this term and are curious what's it all about, this nugget's for you. Let's jump in. Our objective in this micronugget is simple. We want to identify what in the world is a solicited node multicast group, how is it created, and how would we use it? Let's start off with the first question. What exactly is it? To really appreciate the solicited node multicast group, we probably ought to have a basic understanding of multicast groups in general, and to do that, we also ought to compare it to unicast. So let's say we have a conversation with unicast between this PC and this server. This PC has a specific IP address, the server has a specific IP address, and so when the server is responding or sending data to the client, the destination IPv6 address is a unicast address. It's only for PC1, that's it. It gets routed to PC1's network, and PC1 is the only device that processes it. Now let's compare that unicast to multicast. With multicast, instead of sending a packet to the IP address of PC1, we send the IP address to a special multicast group, and they're so easy to pick out. With IPv6, they all start with FF something. So we send this packet to the FF beginning multicast group, and as the packet gets forwarded down the network and to this local network segment, all the devices, let's say there's 200 devices here, all of them would have the opportunity, if they wanted to process and look at that single packet sent by the server. Unicast was one-to-one, and multicast is one-to-many. So with a multicast group, if I have 200 PCs here, and let's say 50 of them care about listening to that multicast content, they can effectively join that multicast group, which effectively means their computers will be looking for that multicast content and de-encapsulating and processing the data as it comes in. The other 150 who could care less about the multicast group don't have to process the data. So what do we know so far? We know that a multicast group is a special layer 3 IPv6 address that's intended for potentially more than just one computer. We also know that a device like PC1 and PC2, if they want to listen and process that multicast traffic, they would join the respective multicast group, and when that traffic comes by on the network, they will then go ahead and be able to de-encapsulate it and take a look at it. So now finally, we have the opportunity to say, what exactly is the solicited node multicast group? And the answer is quite simple. Every device on an IPv6 network, if it has a unicast address, for example, a global address like 2001, DB8, 6783, etc., if it's got a unicast address, it will also, that same interface, will also join a special solicited node multicast group. It's a multicast group that's joined, and it's linked to the actual unicast address applied to an interface. The next question is, how is it created? Well, it's created by adding the last 24 bits of the unicast address as the multicast group address. Let me show you how it's done. We have FF02 at the beginning. FF in the IPv6 world represents multicast. The next two digits, 02, represent its link, local, and scope. Like what happens in Vegas stays in Vegas. Let this multicast stay on the network. Don't route it across network boundaries. That's what the 02 is. Next, we have : 1: FF, which is the telltale sign that this is specifically a solicited node multicast group. And these X's, the last 24 bits, the last 6 characters, represent the last 24 bits of the host ID. So if we have a host ID, for example, here's the network, the first 64 bits. And let's say the host ID was A, B, C, C, 1, 2, 3, 4, 5, 6. That represents the last 64 bits. And this part right here represents the last 24 bits of that, the last 6 characters. With hexadecimal, every character represents 4 bits. So if you have 6 characters, that's the last 24 bits. So the last 24 bits of the unicast address is popped in right there, and that is the solicited node multicast group that this device will join. Now our last question is, so what? Why would we even use that? How is that going to help? Here is how this can help us big time. This PC is very likely configured to use R1 as its default gateway. However, by default just being powered up, PC1 has no knowledge of what the layer 2 address is of its default gateway. How does it learn that? In IP version 4, we used ARP. We send out a broadcast, an ARP request, we get the reply, we'd have the layer 2 information in our ARP cache, and we'd move forward. With IPv6, there is no ARP, and there is no layer 2 broadcast. So what we can use in place of that is some other protocols which involve the solicited node multicast address. You see, PC1 knows the rules on how a solicited node multicast group is created. And because he knows what the IP address is of his default gateway, he's going to anticipate that his default gateway also joined the appropriate solicited node multicast group. And that, my friends, is where the request goes out. We send the request out to our solicited node multicast group that we think the router will be listening on, and if they're both playing by the same rules, the router will be listening on it, and he can respond with the layer 2 address. That's one significant application for this solicited node multicast group. As an example, let's take R1, which currently at the moment doesn't have any IPv6 addresses configured whatsoever. We're going to just do a quick show command, verify that gig 2/0 is empty regarding IPv6. We're going to go to that interface and going to configure 2 addresses. A link local address, which we could leave off because it would automatically generate one for us. I like to hard code mine. And then a global address that starts with 2001. Now that we've done this, we'll issue that same command again. We'll go ahead and do the do show IPv6 interface gig 2/0. Let's take a look at the output. For the show command, show IPv6 interface gig 20, we have our link local address, exactly as we configured it. We also have our global unicast address. Those are both examples of unicast. One's global, one's link local in nature. And let's take a look at this group that it joined. The group that it joined is FF02:1:FF, which is the telltale sign for the multicast group for the solicited node. And check it out. It used the last 6 characters, the last 24 bits that match right here, and also happen to match right here as well. If the link local address had a different last 24 bits than the global, we would have joined 2 separate solicited node multicast groups. And that, my friends, is the magic of what exactly is a solicited node multicast group, how is it created, which takes the prefix of this guy and appends the last 24 bits, and how it can be used. It's a very important process in the neighbor discovery protocol. I've had a lot of fun in this MicroNugget. I hope this information has been informative for you, and I'd like to thank you for viewing.